Now, a force of 36 newtons pulls an object 20 degrees north of due east. So if we think about our graph, this would be east, this would be north. So if we're 20 degrees north of due east, that means that would be what our vector looks like. Now, this force is like our magnitude. So it tells us that that has 36 newtons of force. Now, so I'll kind of underline that in red to show that's our first vector. And then it tells us that a force of 48 newtons pulls at an angle of 42 degrees south of due west. Well, here's west, so if we're at 42 degrees south of due west, I'm going to make that vector a little longer too. So that's 42 degrees would be right there, and this is 48 newtons. I made it a little bit longer because it has a greater force. Its magnitude is a little bit greater. Now, if that's 42 degrees, we don't normally reference our angle off of the negative side of our x-axis. We reference it off of the positive side of our x-axis. So our angle here is really 180 plus 42, or what is that, 222? So that's really our angle there. So it says find the direction and magnitude of the resultant vector. What that means is we need to add these two vectors, okay? So first off, I need to find the component form of this red vector. Then I need to find the component form of this blue vector. Then I'm going to add them. So there's going to be a lot of calculations involved here. So first off, to find the component form of the red vector, we know that I can do magnitude of the vector times cosine theta for the horizontal component, and I can do the magnitude of the vector times sine of the angle for the vertical component. So for this red vector, that's going to be 36 cosine 20, and that's going to be 36 sine 20. And can somebody help me out by doing those calculations?
Sine is 33.8.
Which one is?
The cosine one
It's about 33.8, okay.
And the sine one is like 12.3.
12.3. We'll just round to the nearest tenth. Now, we're going to do the same thing for our blue vector. So there we have 42 cosine of 222. So the exact same process as we did for our red vector. And then to find the vertical component, we're going to do 40. Oh, I said 42, didn't I? That's 48, excuse me, because our magnitude is 48. So 48 cosine 222 and 48 sine 222 to get the vertical component. Can somebody help me out and tell me what those are?
The cosine is negative 35.6.
Okay.
And then the sine is negative 32.1.
Good. We know, I like that because we know it's negative and negative because we're kind of down here in our third quadrant. Now what we're doing is we're trying to find the resultant vector. So what I'm going to do is I'm going to add these two vectors. So I'm going to add the horizontal components and I'm going to add the vertical components. So for my horizontal components, I'm going to add the 33.8 plus the negative 35.6. Okay? You help me out with that one, Bergen?
Yeah. Negative 1.8.
Negative 1.8 would be my horizontal component. Okay, and then what's our vertical component? The 12.3 plus the negative 32.17.
Negative 19.87.
Negative 19.87. Okay. So what our vector would look like is it has a horizontal component of negative 1.8, so not too far, but then it goes down negative 19.87. So probably looks something like this. If we weren't sure, we could do it by making our parallelogram like we did. Oops. And if I make my parallelogram, we can see that our resultant vector would be that diagonal one. Now, we got to be careful though, because we have found the component form of it, but this question actually says find the direction and magnitude of the resultant vector. So this is a really involved problem. So what we want to do next is let's find the magnitude first. So how could I find, if I want to call this last vector, this resultant vector, let's call that vector Q. How do I find the magnitude of Q? Anybody? Pythagorean theorem, exactly right. So I'm going to do negative 1.8 squared plus negative 19.87 squared. And I'm going to square root it. I got a few of y'all helping me with the button pushes. I appreciate that. And did anybody get that one?
19.8,
Yeah, I got 19.8.
It becomes about 19.8. Okay, so that's the magnitude. That's the amount of force or the number of newtons of pull on that resultant vector. And then we're going to come over here. I know I'm kind of running out of space, but we found the magnitude. Next, we want to find the direction. So what we do is we know that tan of theta is going to be equal to the opposite over adjacent. In other words, the vertical component over the horizontal component. So I do tan inverse of the vertical component over the horizontal component, the opposite over adjacent, and that's going to give us our theta. So negative 19.87 over negative 1.8. And that will give us theta. And if somebody could help me out by doing that in their calculator.
185.307.
So before we add stuff, what is it, Colette?
84.8.
84.8. And so this is good. So we got to be careful because the 84.8, we know tangent is positive in two different quadrants. We know that it's positive down here in the third quadrant because it's a negative over a negative, as we see here. But we know it's positive up here in the first quadrant as well because that would be a positive over a positive. We got 84.8 from the calculator when we put this in. That means that if we looked at this like a reference angle, this angle is 84.8, and we need to add 180 to it since we're down in that third quadrant. So if we add 180 to that, what does that end up becoming?
264.8.
Good. So we have to always check our angle and be able to ballpark it. We know because we're down in the third quadrant, angles will be somewhere between 180 and 270. Since we only got 84 degrees whenever we did tan inverse over here, we have to add that 84 degrees to 180 to account for these first two quadrants. So we got our magnitude and we got our direction. The end.